Mathematics is the language of the universe. It is the foundation of all science, upon which rests the building of modern civilization. It is the cornerstone for the technological advancement of the human race. Isn't that exciting?
Yeah, 14. 92.
Columbus sailed the ocean blue?
Wacko?
Yes, Miss Flamingo?
When an apple fell out of the tree and landed on Isaac Newton, what did it teach him?
To sit someplace else?
It taught him gravity, which he defined using mathematics. Dot?
Yes, Miss Flamingo.
If you have 10 cookies and someone takes away half of them, what will they have?
A broken hand.
No!
They will if they try to take my cookies.
They're not trying to take your cookies.
Well, that's what you said.
That's not what I... No, forget it. Just forget it, all right?
All right.
Now, where was I?
I don't know. You told me to forget.
Hey everyone, so that was just a funny little clip to start off our lesson today. So here you are at 3.5 in Big Ideas, Algebra 2, solving nonlinear systems. And so we're going to be looking at what nonlinear systems are. We've looked at already linear systems back in kind of chapter 1. We looked at a 2x2 system, which really was more from algebra 1. And then we looked at also a 3x3 system. We were solving them using substitution, using elimination. We could even solve them with graphing, of course. And that's what we're going to be kind of looking at here, but we're doing it with nonlinear systems. So first, let's go ahead and look at a little cartoon to get started. A little Far Side cartoon. Guy strung up on a tree there. Sorry, mister, but this is what we do to cattle rustlers in these parts. He's strung up to a tree and they're tickling him. It's like tickling him to death, I guess. I don't know. All right, let's go into our nonlinear systems. So on page 67, you have your notes. You have a little, just one vocabulary word there. It's a system of nonlinear equations. So go ahead and just write this little tiny thing down next to that. Just at least one of the equations is nonlinear. So that makes a nonlinear system. So of course, with a system, we have more than one equation. We could have 2 equations. You could even have 3. We're just going to see only 2, though, here in this lesson. So at least one of those equations out of the 2 has to be not a linear equation, nonlinear. So go ahead and write this down also next to that here as you can say, well, this equation here, y equals x squared plus 2x minus 4, equation 1 is nonlinear, and then equation 2 is linear, like a y equals mx plus b. So you had 2x plus 5 there, and that equation 2 is linear. So at least one of these equations, the first one, equation 1, is the nonlinear one. Now you could have, of course, more, you can have 2 nonlinear equations, and it would be a nonlinear system. It's just that both of them are not going to be linear here. One of them could be, and the other one has to not be. Or we could also have both equations not being linear at all. We could have 2 quadratic equations, or we can have a quadratic equation and even another equation we're going to look at as a circle one. So down below in the notes section, so here's actually in the notes section more like these here. Go ahead and draw these. There's 3 ways we can see them. Here's a parabola or a quadratic with a line. That would be what the system looks like here. So if they're missing, this line is missing the parabola entirely, there's no solution. So this would be what the graph would look like. So you could have no solution, 1 solution, or 2 solutions for these. You could have 1 solution if the line just touches the parabola in one spot, so there's only one intersecting point, then there's 1 solution, but it could also go through one side and out the other side, so it could be a 2 solution also system of equations. So you can have either 0, 1, or 2 solutions. And go ahead and draw these as well, because this would be 2 parabolas, 2 quadratics. So if these were 2 quadratics, you have one parabola here, the other one here. If, again, they don't touch each other, there's no solution. So as long as they don't touch each other, there's no solution. If they only touch in one spot, like here the vertex of each parabola is touching each other, so they share a common vertex. So there's 1 solution there, which would be the vertex point. And then this one here is, it's kind of overlapping. So one parabola is overlapping the other, and you can see it's touching in 2 places, so there's 2 solutions on this one. So go ahead and draw these down in the little note section down there. And there's one more I'll have you draw with circles here in just a minute before we get, when we get to those. So let's go on to, I think the next thing is our extra practice. Let's go ahead and try solving some of these with graphing them. We're going to start with just graphing. Okay, so for 1 through 3, we're going to solve these systems by graphing. So we're going to do a little more graphing of, even parabolas, linear ones, lines, in this extra practice here on the first 3. So we got to graph both of these on the same coordinate plane. The first thing you want to start doing is just draw your coordinate planes. Draw the x-axis, draw the y-axis. Just right down the middle for all 3 of these. You can, if you want to pause the video and do that, or do them one at a time, it's fine. But I'm going to jump right in here. So look at number 1. There's a quadratic for the first equation and a quadratic for the second equation. So that's the first thing you want to recognize, is what kind of equations we have. So these are 2 quadratics. They're 2 parabolas, U-shapes. There are no lines in this one. It's all y equals. And remember vertex form. That's how we were graphing some of these. These are actually in vertex form. They could be either standard form or vertex form. So if it could be either, it's better to think of it as vertex form, because that's where we can just see the vertex just from our form here. So for the first equation, equation 1, we were looking for h and k. We can see the k back here. The h would be inside of a parenthesis. Well, there is no parenthesis, so that means there is no h. H would be 0, and the k is this -3. That's our vertex, 0, -3. So that's the first point. That's our starting point to put on for equation 1. Let's go ahead and put that on our graph down here. So it's just down 3 units. Every box is going to be worth 1. And then we also want to recognize it's got a 1/2 in front here. So you could be just doing a little table of values if you want to, or you could remember that parent graph pattern, but you're going to need to multiply the number that you would normally go up by a 1/2. So for instance, when we usually go 1, we square the 1 and go up 1. We go 2, we square 2, go up 4. 3, we square 3 and go up 9. So those numbers, 1, 4, and 9, we're going to need to multiply those by a 1/2. And so we can start doing that. We can say, okay, if I go 1, we're normally going to go up 1, but I'm going to multiply by 1/2 and only go up a 1/2 then. So I'm only just going to go up a 1/2 a box. When I go 1 to the right, when I go 1 to the left, same thing. Go 2 to the right, normally we go up 4, but we're going to go up 1/2 of that amount. So we're actually going to only go up 2 then. So 2 to the right, 2 up. 2 to the left, same thing, 2 up. If we go 3, we're going to go normally 9 up, but 1/2 of that would be 4.5 or 4.5. So we're going to go 3 to the right, 4.5 up. That puts us halfway between these boxes here, between 1 and 2. And same thing on the left. And once we have this many points, really you probably could have drawn it from just these here. You probably didn't even need these last 2. You can graph your kind of parabola, your bowl shape, your U-shape function right there. So that is our first one. Now equation 2, it kind of is a little bit opposite order. Here's your k number, here's the a number. So what I think might be easier is just to switch that order. So I'm going to do that and put the -2x squared first, then the -4 second. That way I can kind of see it more in the vertex form. And again, it's like the other one where there is no h. H again is going to be 0. Our k is the number here in the back, -4. So 0, -4 is going to be our number this time for the vertex. So let's go ahead and plot that point, which is right below the last vertex, 1 unit down below it. And we also want to recognize, okay, which way is this opening? Well, a number is negative, it's going to open down. So we can already tell the answer for this one. These are not going to touch. So I'm just going to graph this one real quick. We would normally go 1 and then 1, but we're going to multiply by 2. We're going to go 1 and then -2 down. So I'm actually going to go down a little bit there. I'll put some points there just to show you where the graph would be. And then 1 to the left, 2 down, and we can go graph that from there. But we can tell definitely these are not touching. So if they don't touch, there is no solution. There is no ordered pair intersections. All right, so number 2. First one is a parabola. Again, this one has an h in here, but there is no k. So we can see our vertex. It's opposite of what you see here, x -2. So the h number is +2. And then the k number is not there, so the k number is 0. So we can start first with just plotting that point right here, 2 to the right, and there's our point. And then we want to just see, okay, what shape is this? It's the same shape as the parent function, so we can just go off of that. So 1 to the right, 1 up, 1 to the left, 1 up as well. So we're going to put those up there. So 1 left, 1 up, 1 right, 1 up. And then if I go 2, I'm going to go 4 up. So 2 this way, 4 up, 2 that way, 4 up. And we'll do that there. And then we just can draw our graph from those points. And there's our parabola. So you can always remember to do that if it's the same shape as the parent function. Right here, the a number is still 1. See, there's no a in front here. So if there's not a number there, then it's a 1, which is the same as the parent function graph. There's a 1. So you can just go off of that pattern. The next one is a line. So we are going to have a parabola and a line here. So this is in y equals mx plus b, our slope and our y-intercept. So our starting point is right there, -1/2. That is the y-intercept. We want to plot that on our graph first, and then see the fraction here of 1/4. This is the slope. It's rise over run. So rise is a 1, and the run is 4. So the first thing to plot is the -1/2 on the y-axis. That's going to go down just half a unit. So it's right in there. And then using rise over run, we're going to go up 1 and right 4. So up 1 puts us at +1/2, and then right 4 puts us all the way over here. So we'll plot a point there and draw our line. And as you notice, the line is also in the same line as this vertex point here. So the line goes right through the vertex point. So that's your intersection. That's where the graphs touch. And so that's your answer. So that point is the 2, 0 point. That is our answer on this one. All right, number 3, we have another parabola here. And then we also have a line here. So on this line, what you want to do for the line is you want to distribute this. So it's going to be 4x plus 4, and then combine like terms to get y equals mx plus b. So I'm going to give you a chance to try this one. Go ahead and try to graph these two. Graph the parabola, graph the line, and see if you can identify the intersecting point or points on this one. So go ahead and pause the video and try number 3. Okay, hopefully you got a graph here, and you're just checking your answer now. So we want to graph this top equation, the first one, and this one you can see it's going to open down because it's negative. There is no h because there's no parentheses. So the h is 0, k is the -2 number. So we can see our vertex is 0, -2. We can plot that point first. So right here, 2 below the origin, and we know it's going to be opening down here. So it does have the same shape though as the parent graph. It's just going the other direction. So if I go 1 to the right, I will go 1 down, and 2 to the right, 1 down, or 1 to the left, 1 down as well. So we can start with those points. 1 right, 1 down, 1 left, 1 down. If I go 2 to the right, I'm going to go 4 down. Remember, we're squaring the x numbers here. So 1 squared, 2 squared, 3 squared. That's tell you how much to go down in this case, because we're going down. So we're going to go 2 to the right, 4 down, 2 to the left, 4 down. That's enough points. We can just go ahead and draw our U shape from that. And then we're going to draw our line. So like I said here, you're going to distribute 4. So it's going to give you 4x plus 4 and minus 3. We'll combine these here. That just makes a plus 1. So y equals 4x plus 1 is our slope-intercept form. You can see the m is 4 and the b is 1. So remember, you start with 1 first. We're going to plot that point first. We can put 4 over 1 to see rise over run. So 4 is the rise, 1 is the run. So let's start with plotting 1 on this y-axis right here. So we'll put that there on the y-axis. And then from this point, we can go up 4 and right 1. They're both positive. So if you go up 4 units, it takes you to the top here. Right 1, you can put a point there. Now it might be helpful to go the opposite direction, which would be go down 4 and left 1. And if you do that, notice that's already red there. So I already showed you that's going to be a red point. That's going to be an intersecting point right there. If I go down 4, right 1, that's the same point. So we can draw our line right through that point there. So that is the intersection. So it's going to be -1, -3 for the answer to this problem. -1, -3 is the point of intersection. So just one answer because it only touched the graph in one place. Okay, so problem 4 and 5 says solve the system of nonlinear equations by using the graph. So this made it a lot easier. They're just showing you the graphs already. What are the solutions? You could have no solution, 1 solution, or 2 solutions. So go ahead and do number 4 and 5 and then check your answers to see if you're correct. So go ahead and pause the video and do 4 and 5. Okay, so hopefully you got answers for these. These do not take very long because you're just looking for where they're intersecting. So right here you have a parabola and a line. So here's one point of intersection right here. Now the one thing to realize is the x-axis is going by ones. The y-axis is going by twos. So if you thought it was going by ones here on the y-axis, you may have made a mistake with the number here for your y number. So it's -1, but then it's going down 5 boxes, which really is 10. 2, 4, 6, 8, 10, -10. So the actual intersecting point is -1, -10. If you put -5 here, just fix that because you didn't realize you're going by twos down the y-axis. The other intersecting point over here on this side, that's going 2 on the x and also down 10. So +2, -10. Number 5, these two parabolas are not touching at all. Okay, so if there's no touching, then there's no solution. So that's easy. All right, let's go on to now doing these. We did graphing. We're now going to go on to the substitution method and the elimination method as well to solve these systems of equations. Okay, so back on page 67, back on those notes section, I just want you to also include the circle with those graphs as well that you drew. So go ahead and write this down there for the circle graph. So x squared plus y squared equals r squared. This equation is the standard form of a circle with a center at 0, 0 and a radius r. So go ahead and write that down. You haven't really seen this yet because you haven't taken geometry, and you will see it when you do take geometry. It's in the end of the book in geometry in chapter 10. And so you will be being more introduced in graphing circles at that point. But also include these. It's the same basic principle. If the line is not touching the circle, there's no solution. If the line is touching the circle in just one spot, then there is one solution. And if it's going through one side, out the other side, it's touching in 2 places, so there's 2 solutions. So that's what the graphs could look like if you had a line and a circle graph. Circle graph would be where x squared and y squared, they're both squared here. So that's the one thing I want you to recognize from your equation, is that when you see an equation that has both x squared and y squared, well, there we're talking about a circle graph on that one. Okay, so we're going to get into the solving these with the substitution and elimination, and we might see some circle equations in there. Okay, so on page 66, it says solve the system by substitution. And so we have a linear equation on top on this first one, number 6, and a quadratic on this one. It's in vertex form. But they're both equal to y. That's one thing to realize and see. If they are both equal to y, then these both can equal each other. So we can kind of just do a little quick substitution with this x minus 4, put it there where this y is, and so now they both will equal each other. So the x plus 4 is going to equal this binomial squared, the x plus 2 squared, plus the 1. And so now what we would need to do is actually, make this back into our trinomial, convert this this x plus 2 squared back into the trinomial that we would need it to be. So we'd have our x plus 4 still over here, and the trinomial for this is going to be x squared plus 4x plus 4. Now remember, this 2 was the special number, 2 times 2, 2 plus 2. Makes your trinomial. So you have your x squared. So if this is just a 1x squared, it's just x times x, giving you your x squared for the first one. For the x term, it's the 2 plus 2. For the c term, it's the 2 times 2, but they end up both being 4. But then we still have this plus 1 that we need to put behind here still. From our k number, so we have to add that in. So it's going to make this a 5 now here. And as we're doing this, with your adding with 5, we're also going to be bringing these two terms on this side to kind of reset it to standard form, because now we have a quadratic equation. We want to solve this. It's good to reset to standard form, so we want to make it equal to 0. So I'm going to be subtracting x and subtracting 4, bringing these over here. So as I'm doing that, I'm going to have subtract x from both sides, subtract 4 from both sides. They cancel here. This leaves me with 0 on the left. Over here I'll have an x squared. 4 minus 1 is 3x. And then these 4's cancel here, so that just leaves with plus 1 still. So our equation now is going to be x squared plus 3x plus 1. That's the quadratic equation we need to solve. It is not factorable. That's not going to work out because there's not two numbers that multiply to give you 1 that add to 3. So that doesn't work for factoring. It also, complete the square is not a good option, so plan B is not really the way to go because 3 is an odd. So I would go with our plan C, which is always the quadratic formula. So let's go ahead and plug it into the formula. So remember, that's the little opposite of b, plus or minus square root of b squared minus 4ac all over 2a. That's what we're plugging this in now. So a is 1, b is our 3, and c is 1. So b is 3, so it's opposite of b, negative 3 plus or minus the square root of b squared, so it's 3 squared there, minus 4 times 1 times 1. That's a and c. Both a and c are 1s, and it's over 2 times 1 for 2 times a. So you're just plugging your a, b's, and c's into this, and now work this out, simplify this. So underneath the quadratic, or the square root here, we're going to get 9 minus 4, because 4 times 1 is still going to be 4. 9 minus 4 over 2. So that's going to be 9 minus 4, giving us 5 under the radical sign. So negative 3 plus or minus the square root of 5 over 2. Now that's our answer. That could be our answer for the quadratic equation. But because we're trying to solve the system, we actually need to get 2 ordered pairs. So to do that, we need to make sure we figure out what the actual decimal number for these are. So we're going to have to do that. We have to figure out, okay, it's square root of 5. What is that? So we can go to our calculator and do 5 square root. That's 2.24 if we round it up to 2 decimal places, or 2.2 for 1 decimal place. So we want to change that. I'm just going to do 1 decimal place, 2.2. So it's going to be negative 3 plus 2.2 over 2. So one of the x's are going to equal this. Negative 3 plus the 2.2 over 2. So when we actually work that out, so if I do that on the calculator here, I already have kind of my 2.2 there. If I say, okay, minus 3 from that, it's a negative 3, and then divide it by 2, that gives me a negative 0.38. We can round that up to 1 decimal place to negative 0.4. So that's going to be negative 0.4 that. Now, since that's our x, to find the corresponding y, we would also need to plug it into x in one of these 2 equations. The easier one is going to obviously be the top one, the linear, because just y is equal to the x plus 4. So let's do that here. So what does the y equal when x is negative 0.4? So y equals x, negative 0.4 plus 4, and then that becomes 3.6. If we take 0.4 away from 4, that's 3.6. So that gives us 1 ordered pair for our answer. And out the other one, down here, we still have to subtract the 2.2. So this is for the second answer. We're going to get 2 answers here on this one because we have a plus or minus showing us we're going to get 2 answers for x, so there's going to be 2 ordered pairs. So negative 3 minus 2.2 divided by 2. So that's going to be negative 5.2 divided by 2, which would end up giving us negative 2.6. And if we plug negative 2.6 into that same equation here and then add 4 to it to find the y, if I take 2.6 away from 4, that's going to give me a 1.4. So this is also another ordered pair. So our 2 answers should look like this here. The one here from negative 0.4, comma 3.6, and the second one from negative 2.6, comma 1.4. So those are our 2 ordered pair solutions. If we were to graph these 2 equations, we would see it, those are the 2 x-intercepts, or they would be approximately those numbers. We obviously rounded them to 1 decimal place. So let's go on to our next one, number 7. We're going to go to the graphing calculator. In fact, I might show you first number 6, then we're also going to do number 7 on the calculator. Okay, so here's the graph of those last 2, so you can see the parabola and the line, and here's our intersecting points. There's one of them at negative 2.6, 1.4 if we round to 1 decimal place, and here's the other one at negative 0.4, 3.6 for the other one if we round to, again, 1 decimal place. All right, let's go on to number 7. 7 now is going to give us an x squared plus a y squared. That's the circle graph. So this is one where the center is at 0, 0. And our radius would be the square root of this number. So square root of 16 would give us our radius. So the radius would be 4. So that means if we put a point, that would be our starting point at 0, 0. And then if we go 4 to the right, 4 to the left, 4 up, 4 down, that would give us at least 4 points. We can see that's going to be on the circle. So that should be easy to graph. And then you can always graph this line very easily with the y-intercept. Here's your starting point there. You'll start with 4 on the y-axis. And you can see that's going to be one of your points, is the y-intercept is an intersecting point. So let's go back to the graph and plot these in, or plug these in and see what they look like. Okay, so I already typed them in. There's our circle graph, x squared plus y squared equals 16. So here's our circle. Like I said, the radius is 4. You have 4 to the right, 4 to the left, 4 up, 4 down. You can see that. And then there's our line. Slope is 4, so you start at 4 right up here. So you can see there's one of the intersecting points is right there at 0, 4. And then your slope is -1, which means to go down 1 and right 1. Down 1, right 1, down 1, right 1. You keep doing that, you'll hit the other intersecting point right there at 4, 0. The x-intercept is also, so the x-intercept and the y-intercept for this line are the intersecting points of this system. So let's go back here and look at our answer. So our answer for this one is going to end up being just 0, 4, and 4, 0. Now I showed you the graph because I thought that was the easier way to actually do it. We could probably find them easier. It says use substitution, so we could have taken this negative x plus 4 and plugged it in here for y, but we would have had to have done a little more algebra and squared that binomial and then simplified, solved a quadratic. So it went a little more challenging, I think, to actually do it that way than even the graphing way for this one. All right, for number 8, now these ones may look a little more challenging, but we still just have two quadratics. There's only x squared in the top one, only x squared in the bottom one. And this right here says y is equal to this. So we can use substitution here. We have one y letter up in the top one. So what we'll do there is that these two terms, we'll just replace this y. So we're going to write down these three terms first. So the 2x squared plus 10x plus 48 is equal to. Then we're going to write these two terms next. So negative 4x squared minus 16x comes next. And then we'll write that negative 10x again. And you can put it here or you can put it underneath this one because you are going to have to combine like terms. I put it actually below it. It doesn't make any difference. You're going to be combining these eventually to make a positive 20 or make a negative 26x on that. So that would be a negative 26x there. So since this is a quadratic, we want to reset it to equal 0. So reset to standard form. So we want to move our 4x squared here. We want to add 4x squared to both sides. And since this would be a negative 26x, we want to add 26x to both sides as well. So we're going to cancel them here. So I'm going to cancel out the 4x squareds with adding 4x squared. Cancel these two terms with adding 26x. That would cancel those out. And now I'm going to do the same thing over here. I'm going to add 4x squared. I'm going to add 26x to the other side also. So that now gives me 6x squared, gives me 36x, and the 48. So that's our now new equation in standard form. And we'll notice that we can reduce this equation because the 6 here can go into 36 and it can also go into 48. So it would be best if we reduce this entire thing by 6. So divide everything here by 6. You can divide 0 by 6, but you don't have to. It's really not necessary. You're still going to keep that as a 0. So 6 divided by 6 will be x squared for your first term. This will be 6x for the second one and plus 8. So there's a much simpler quadratic equation to work with. And this one is factorable because there are two numbers that multiply to give us 8 that would add to give us 6. So we can use our simple method factoring for this. Just simply put the x's up in front, break that x squared apart to 2x's, and put the 4 and 2 here as your numbers. They're both the same sign. They're both positive. You can always use FOIL to check factoring anytime. And now we've just set each one equal to 0. Use the 0 product property. And so now we're going to subtract 4 on this first one. That's x equals negative 4. Subtract 2 to get x equals negative 2. So that gives us our two x numbers. We need to now find the two y numbers. So we're getting two ordered pairs here. So we're going to have to pick one of these equations up here. And it would probably be faster or easier to pick this second equation just because it's a little smaller. So negative 4 times the x squared minus 16 times the x will tell us what y equals. So let's go and plug that in for x equals negative 4. So negative 4 times negative 4 squared. So this whole term right here, that's going to be positive 16 times negative 4. So this is going to be a negative 64 when we do that. You can do this all in the calculator. Negative 16 times a negative 4. Well, negative times negative, we know is positive, and this also makes 64. So we're going to get negative 64 plus 64. So the y in this one is going to be 0. So that gives you one answer. One of your ordered pairs is negative 4, 0. I'm going to put that up here on the top for our answers. So negative 4 comma 0 is one of the answers to this system. Now if we plug in negative 2 to that same second equation, so negative 4, starting with negative 4, times negative 2, so the x number on this one is negative 2. So we're going to do negative 2 squared, which is 4. So positive 4 times negative 4 is negative 16. And then negative 16 times the x number, negative 2, that's making positive 32. So we're going to get negative 16 plus 32, take 16 away, that's going to be positive 16 for the y. So our other answer is going to be x is negative 2, y is 16. And then there's our other second answer for the ordered pair. So those two ordered pairs are the answers, are the intersecting points to this system. All right, let's take a little quick short break for a joke of the day. So here we go. What do you call a pig that does karate? Pig that does karate. Let me mentally picture a pig doing karate. What do you call a pig that does karate? A pork chop. Because he does his little hi-ya. Okay, so we're solving the system by elimination now from 9 through 11. So the elimination is where we're going to combine the two equations together and try to eliminate one of the variables. So we have to kind of be a little strategic and figure out which variable do we want to eliminate and how do we do that. So looking at 9, we have a quadratic equation on the top because it has an x squared, a linear one on the bottom because there's no x squared. Both of them is just x and y. So what would be good if we're going to use elimination is get everything that's the same on the same side of the equal sign. So here's our equal sign here. We have x and y on the left, but in this equation we have just x on the left, y's on the right. So it would be good if we would move the y then for this equation over here to the right. So let's go ahead and subtract y first on this equation. So now it'll have just the negative x. I'm going to go ahead and put it right above this other equation here so we can see it, and right above this corresponding x term here. So the only term left on the left side of the second equation is a negative x. So we'll put that right above there. The two terms here, because those are canceled out here now, two terms on this side is a negative y and a negative 4. So I'll go ahead and put the negative y above this y, the negative 4 above the negative 1 there. So it equals negative y and minus 4, and they're right above what they're going to correspond with, so they're going to combine with those nicely with the like terms. So now that's what we want to do. We want to now combine like terms. So this equation here, we're not going to pay attention to it anymore. We're just going to now look at these two. So here's our kind of a new equation 2 with equation 1. As we combine these together, we're going to get just an x squared, and this will make a negative 8x, and then we'll have a plus 11 on that side. On the other side, we're going to be able to cancel out these y's right here. So there's where we're canceling out the y's. Now, as I was doing this, as I was subtracting this, I needed to realize I had to cancel out one of the variables. Well, the best one to cancel out is the one that's not being squared, because you don't want to cancel out x, because if you cancel out this x, well, you still have an x squared there, so you really didn't cancel out the x at all. So the one that's not being squared is the one that you really want to try to cancel out. So that would be the y's in this case, and since they were opposites already, that worked out nicely. And then we're going to have negative 5 over here. So that's what we're going to get. Our x squared here, these two combined together, negative 8x, our plus 11 is equal to these two combined to negative 5. So there's our new quadratic equation that we can now solve in just the one variable of x. So we might want to reset this to standard form so we can kind of see what we're working with. So we're going to add 5 to both sides. So that's going to give me 0 now on this side and 16 over here. Our c number will be 16. And, that is factorable. So this actually is a trinomial square, because you can think there's a special number, 4 times 4 and 4 plus 4. So this would be one of those trinomial squares that we could factor to a binomial squared using the 4 special number. So you have your x, your minus sign from the middle term there, and then that special number. 4 times 4 is the 16, 4 plus 4 is the 8. And so that gives us that with a square there equal to 0. So we could take the square root of both sides if we want to do that, or just set this factor equal to 0. We don't even need to take the square root. We can just say they're both exactly the same. So x minus 4 is equal to 0. And just add 4, so your x is 0. Now that almost looks like an inequality sign. It's not supposed to be. That's just an equal sign there. X is equal to 0 now. Or sorry, x is equal to 4. So we're going to plug 4 into one of these equations. It would be always easier to do the linear one. So if x is 4, it's going to make negative 4 here, plus y equals negative 4. So we're going to go ahead and plug that in. So negative 4 plus y equals negative 4. So I'm plugging in 4 for my x in the second equation here. And then we'll just go ahead and add 4 to both sides. So y is equal to 0. So our answer for this one, again, this is equal to 4. X equals 4, y equals 0. Our ordered pair is 4, 0. So that's right up here next to the equations, next to number 9. There's our answer, 4, 0. So the intersecting point of where this parabola, the U shape, and this line is just going to be one place at 4, 0. For number 10, they both equal y. So if they both equal y, they both can equal each other. We could say that. So if we wanted to substitute, we could do that. Or what we're going to do here is by canceling out one of the variables. So the one variable you would want to cancel out if we're going to do elimination is the y's, because you want to cancel the ones not being squared. So we're going to cancel out the y's here. And everything is lined up nice and neatly already for us. So this one's going to be a little easier. The only thing we do need to do is make one of these y's opposite of what it is, because they're both positive right now. One needs to be negative. So let's just make the bottom one here. Multiply the entire equation by a negative. You can't just multiply the y by the negative and not the rest. So if we're going to make y negative, then we have to change the signs of everything else. So x squared changes to negative, the negative 8x changes to positive, and negative 19 changes to positive 19 there. So now we can combine every like term together, starting with the y's. They will cancel each other out. And so that would make a 0 equal to 9x squared minus x squared. It's 8x squared there. These two will make 14x, and then these two is 21. So with this quadratic equation, we got to solve the quadratic. So there's going to be possibly two answers for x. Factoring, I wouldn't try to factor this one, because even if we did, we're going to have to use the star method. You can't simplify this by anything. There's nothing that goes into all three of these numbers that would simplify it. The completing the square, it wouldn't work very well because there's a number in front of your x squared. So I would just go straight to the quadratic formula. A is 1, B is 14, C is 21, and we're going to plug it all into our quadratic formula. So starting off, x is equal to opposite of b. So that's negative 14, plus or minus the square root of 14 squared. Then the minus 4 from the formula, times a times c, so it's times 8 times 21, and it's all over 2 times a, so it's 2 times 8 at the bottom. And now we just simplify 14 squared, so we're going to still keep this negative 14 in front, so negative 14 plus or minus, the square root now simplifies, so 14 times 14 is 196. All of these numbers here, 4 times 8 times 21 makes 672, and it's still negative because there's only one negative out of those. And so it's over 16, and 196 minus 672, we're going to notice we're going to get a negative answer for that underneath the radical sign. So if there's a negative answer, that means we're going to get imaginary solutions. So that cannot be graphed on a real number line, so there is no solution then for this one. So one thing here to keep in mind is if you get any imaginary solutions as answers, those are going to be no solution answers for our system of equations. There is no point of intersection here. So no solution answer. So that would be like if the parabolas, these are both parabolas here, are not touching each other. So if they're not touching each other, then they probably don't have any solution, of course, and they're probably going to be maybe even imaginary answers for them as well. Number 11, so this one is not quite set up as nicely as number 10 was. This one we want to try to move things around, I think, to get them on the same side. So the first thing I do notice is that, well, I do have my x squared here on this side, but I have really two x squared terms on this one. The y's that I want to cancel out because x is being squared, so we want to cancel the one that's not being squared. So I'd want to get those definitely on the same side. So what we could do is we could just kind of flip this around, in fact. So I'm going to put these two terms on this side and these two terms on that side. So I'm just going to kind of flip it around. First, before I even do that, we do need to make this y negative. So maybe as I'm flipping around, I can do that, or I could just do it right now. So if this y needs to be negative, then everything needs to change signs again, just like we did on the second one on number 10. So this is now going to become, so this was negative 5x, now it becomes positive 5x. That becomes negative 29, becomes negative y, becomes a positive x. So that way all the signs change. So when I do combine it with the positive x below, those will cancel out. But again, I need them on the same side of the equal sign. So I'm just going to flip it over the equal sign. You can always do that. So now we're going to have on this side, I'm going to just kind of line up the terms though. I have an x squared, lines up with that x squared. The y term lines up with this y term, and they are opposites. And then these two are going to go on the other side. The positive 5x, the negative 29 is going to come over here on this side. So x squared and x squared make 2x squared, and here's where we'll cancel out the y's, so those cancel out. So that will give us a 2x squared is equal to 2x squared again on the other side. And then you have your 5x, and those two make negative 30. Well, notice I crossed out the 2x squareds here, because if I was to subtract 2x squared from both sides, they're going to cancel each other out. So we can cancel out, if there's the same thing on both sides, we can cancel that out. So that leaves us with 0 now over here and just these two terms. So 0 equals 5x minus 30. Let's go ahead and add 30 to both sides, bring the 30 to the other side. So that's going to be 30 equal to 5x, and divide by 5. So here x is going to equal 6. So you can tell we're only getting one answer for x. There's only going to be one ordered pair solution on this one. There's only one intersecting point. So we still need to plug 6 back into one of these equations. It doesn't matter which one. So let's see, I'm going to choose the second one here. So the one that doesn't have the 29 in it. So our second equation, we're going to plug it in. So if x is 6, it's going to start off with x squared. So 6 squared plus a y is equal to 2 times x squared again, so 6 squared, then minus 1. And here you just want to simplify everything and solve for the y. So we have 6 squareds both here becoming 36. So this will be 36 on this side. This will be 36 times 2, which would be 72 on that side. So we're going to get 36 here plus y. 72 minus 1 is 71 now on this side. And all we have to do is just subtract 36. And so now 71 minus 36 gives us y is equal to 35. So there is our ordered pair now. X is 6, y is 35. That's the ordered pair solution. So you can go and put that on the top up here. That's our intersecting point, our point of intersection for both of these parabolas. All right, moving on. We just got a couple more problems to do before we're done. All right, so number 12 just says consider the following. Here's a system. You have x squared and y squared, which would be a circle graph on this first equation, only x squared, so you have a parabola here. Letter A just says, which method would you use to solve the system? So, would we use graphing? Well, probably not. That might be a little more challenging to try to graph it ourselves. Would we use the substitution or elimination method then? Which of the two of those would be better? Well, because it says just this x squared right here, x squared equals 9 minus y squared, we can take this right here and plug it in for the x squared that's right there. So I would use substitution. Oops, S-T-I-T-I-O-N. I would use the substitution method because I could do this. And I'll just show you, I would start off with this x plus 2y here is equal to 2 now, multiplying, instead of x squared, we're going to put this in. So replace the entire x squared with that. Right there. So that whole thing was what x squared equaled. And we're just going to, instead of x squared, we're going to put that in, and then we could continue on with this. So that would be something we could do. We could then now just have y in our equation. Actually, no, we still have x in our equation, sorry. That's okay though, because there's an x on both sides. So that's what I was thinking of earlier and forgot to mention. We could have said that right up at the beginning. We should have probably done that from the beginning and said, okay, we have an x on both of these sides, so they can cancel each other out, kind of like we saw in that last problem where we could cancel the same thing on both sides out. So I really didn't need to put these down here at all. They could have just been that. minus those x's. So that now just gives us an equation in y using substitution. Then the second one, B, says, would you have used a different method if the system had been as follows? So where basically the squares are gone now, and now it's just a linear equation. This is still the same equation. So again, we still can cross out these x's here. They can be gone. And I would still substitute in, I could still substitute this in for the x that goes right in there. I would still use substitution. So would I use a different method? I would say no. Still going to be substitution. So still, I'll just put sub for substitution if I can't even spell S-U-B. So if x is equal to this, I would write this down now. 2y is equal to 2 times, and instead of x, not the whole x squared, so the squared's still going to be here, but x is now 9 minus y, and we got to square that. Because we're not getting rid of the square, we're only just replacing the x. And then we could put plus 7 after that. And now again, we only have y in the equation, so we can just simplify this, solve for y then first. All right, last problem, number 13. Okay, so problem 13, they want us to actually write a system of equations and then solve it. It says the sum of two numbers is -5, and the sum of the squares of the two numbers is 17. What are the two numbers? So we want to write two equations for this. So our first equation is going to be from this first one here with the -5. The sum of two numbers is -5. So if our numbers are just x and y right now, use those two variables for your numbers. Sum means to add them. So if you add x plus y, it equals -5. There's one equation. It's just a linear equation. But then the next one here, it says the sum of the squares. So the squares of each of these. So the square of x, the square of y. So x squared plus y squared, the sum there is 17, equals 17. So that's the second one there. So x squared plus y squared is going to equal 17. Okay, so now at this point, we would want to find these two numbers by solving this system. So the first thing to do is write the system out, and now we need to solve it. And we could use, now this one you wouldn't want to use elimination because you have x squared, y squared here and only just x and y here. So there's no way to cancel these out. You can't put these together because they're not like terms. So you would have to be using substitution, or you could try using graphing as well, I suppose. But you definitely have to use, not elimination. You can't use that one. You use substitution here. So we want to solve for one of these two variables, either solve for x or solve for y, and it doesn't matter which one. I just chose to solve for y here, so I'm going to subtract x, kind of like a y equals mx plus b kind of equation here. So I'm going to subtract x from both sides, and so that's going to end up giving me, x's are going to cancel here, it's going to give me a y is equal to -x minus 5. So I'm going to have a new equation here. New first equation of y is equal to -x minus 5, and now I can take this and substitute it in for y into this circle equation here for that y. So that can now replace the y in that circle equation. So this circle equation is going to start off with x squared. So we'll start it with x squared plus, and then this -x minus 5 is going to go in a parenthesis, and then that parenthesis will be still squared because we didn't get rid of the square, just the y. Just replace the y. And then it will equal 17 from that circle equation. So now everything is in terms of x, and we want to start to simplify this, and we need to figure out what is this binomial squared can become. So we start off with the first x squared here. Let's bring that down still. And then to multiply this, a binomial squared is the same thing as saying the same thing times itself. So two binomials exactly the same are getting multiplied. And we can use FOIL to do this. So -x times -x would be x squared. The outside would be a positive 5x. The inside would be also a positive 5x. And your last ones, -5 times -5 would be positive 25. These two middle ones you can combine and get 10x out of that. So now what we're going to see here is after this first x squared, we're going to write this now. Yeah, add this in. You're going to say plus x squared plus 10x plus 25 from the square of this binomial as this trinomial here. And then it will still equal 17. So that's still going to be 17 there. So now at this point we can combine the x squareds together. That's going to give us a 2x squared. We also can maybe reset this to standard form by subtracting 17 and bring it to the other side. So we can do that as well. So as we combine the 2x squareds here, and then we're also going to combine 25 minus 17, this will become 0. So it's going to be 2x squared plus 10x plus 8, that's the 25 minus 17, equals 0. And you can see that they're all even numbers, so we can reduce this entire equation by 2. So that's the best thing to do now. Yeah, let's reduce it by 2 by dividing everything by 2. So it's going to give us just an x squared here. 10 divided by 2 is 5, and this will be 4. So we're going to get an x squared plus 5x plus 4 is equal to 0. Now that gives us a trinomial, and this trinomial is factorable because two numbers multiply to give us 4, which also add to give us 5. Those numbers will be 4 and 1. 4 times 1 is 4, 4 plus 1 is 5. So we can now make two binomials out of this. Let's break apart the x squared with using just simple method, factoring. So x and x go up in front, the 4 and the 1 are your numbers here, and this plus here means they're going to be the same sign. They're both going to be this sign, both positive. And you can always do the FOIL like we did here with these two just to double check that you got that right and factor that correctly. And now just each of these get separated and set equal to 0 separately. So x plus 4 equals 0, which will subtract 4 and get x equals negative 4 for that one. And then x plus 1 equals 0, so subtract 1, you get x equals negative 1. So we're getting two answers here. We're trying to get the two numbers, right? So what are our two numbers? So at this point, we want to see, okay, we got negative 4 and negative 1. We're trying to get ordered pairs first, and then we can decide what are the two numbers at that point. So let's go ahead and plug these back into one of these equations up here. We can put it to the top one. We can even put it to this one as well. So x is negative 4. So let's go ahead and put that in there. So far we found x. Remember, our two numbers are x and y, so we need to figure out what the y is going to be. And we have two possibilities of what it could be, just like we have two possibilities for x here. So when I plug negative 4 back into our top equation, it's negative 4 plus y equals negative 5. That's what I'm doing there. And I'll add 4 to both sides. So negative 5 plus 4 is going to be negative 1. So y equals negative 1. When I plug in negative 1 plus y equals negative 5 and add 1 to both sides, that's going to give me negative 4. So my two numbers are the same numbers that I got down here. So one of the numbers is got to be negative 1. The other number's got to be negative 4. So the sum of them, yes, it does work out. The sum, if you add those together, it makes negative 5. If you were to square them, negative 1 squared is 1, negative 4 squared is 16, and 1 plus 16 will give you 17. So that works in our, what it says up here. So our two answers then are just negative 1 and a negative 4. That's it. All right, so that concludes our lesson on the nonlinear systems. You want to do your assignment now, and I'll see you on the next lesson.